Can everyone hear me? Perfect. Welcome to United Astronomy Clubs of New Jersey. Thank you for joining us for our last on site presentation of the 2024 season. I want to give a big thanks to all of you who have joined us not only here, but also online, because that is right. We do live stream these every time we do them on Twitch and on YouTube. So while I see a couple people coming in, getting settled, couple notes, you can look us up on our website, uacnj.org. That's where you're going to find a list of all our member clubs, because we are a club made up of other clubs. So some of the best ways to get into astronomy, or really anything, is to find the local club who can give you all those tips and tricks, and it's conveniently located. In addition, it has a list of all our upcoming talks. So from our next presentation, which is the first Saturday in November, we will be online only, just because as winter sets in and ice sets in, unfortunately, insurance gets a little too much. So you can still join us online on YouTube. And if you look on our list of talks and you're like, man, I'm so sad I missed that talk on the Fermi paradox, do not worry. Go onto our YouTube channel and you can find those there. In addition, you can look us up on our social medias, our Facebook, our Instagram. We have a Discord channel. All excellent ways to get in touch with us, ask questions, share your astrophotography. We had a number of people share pictures from the comet and the aurora that happened recently, and we do love to see those. So, but since it looks like most of the people have wandered down here, it is now time for the safety briefing. If you need to use the restroom, it is the porta potty in the back to my left, your right. It is illuminated by red for ease of finding in the dark. We are in a state park, so not as many lights, which is great for stargazing, not so great for finding things in the dark. In addition, we have a museum and gift shop area. I will be manning that after the presentation and question and answer session. Each of those sheds you saw when you came in houses its own telescope. The ones with the roofs rolled back are open and have a volunteer running that scope. Feel free to ask them what they're viewing tonight. And if you have a favorite object, and if it happens to be up, a lot of times you can ask them and they will try and get that view in there. In addition, do be mindful of our volunteers. Great resource to ask any questions, and if they have any directions, do please follow that. When we're walking around, any lights we may have, like flashlights, do try and keep those lights pointed towards the ground. We don't want to accidentally blind people. However, we are going to be using our headlights when we leave, because I don't know about you, but I cannot afford the medical bills for getting run over. So we are going to avoid that tonight. We have avoided it all season. Congrats. I'd like to keep that record going. So do use your headlights. In addition, it is close to Halloween, and I like being festive. So thank you all for who have joined us in costume. I also have a little bowl with some candy. I also have one of the teal pumpkins with some toys and like squishy toys in it, and one of our volunteers, or past volunteers, current volunteer, has also brought some fun space toys and puzzles and the like. So do feel free to partake in those. They are over on my desk over there. But you're not here to have me rattle on for forever. You're here for a great talk, which is The Universe Can Be a Scary Place by Walt Windish. Helps if I'm on the correct side of the book. Walt has been interested in astronomy since he saw the Pleiades as a Boy Scout. He bought his first telescope in 1985, just in time to see Halley's Comet. Walt is a member of the North Jersey Astronomical Group and the Rockland Astronomy Club, and been volunteering here at Denny Jump for many years. And with that, Walt.
Thanks, Kim. Thank you. And thanks to all of you for coming out on our last night of the season. Uh, the Halloween night can be kind of iffy. I remember 4 or 5 years ago it was down around 30 degrees, and it was me and the volunteers. Period. So thank you so much for coming out. It means something for me. I like to do a talk whenever I can. With the universe is a scary place, and I pick a few objects that are scary because there's a lot of power behind the beauty. I pick some events that could be of concern to people living on Earth. Don't worry, it's going to be thousands of years out, or at least hundreds of years out. But there's some cool stuff we can talk about there. And then I'm just going to pick some stuff like nebula that looks scary through the telescope. And remember, when you look through a telescope, you're really going to see it's going to look like a foggy or cloudy object. You're not going to see the beautiful colors that you see that from a space telescope. Our eyes act like a camera that has about a 1/30th of a second exposure, and you don't get much color from a night sky with that. The pictures you see with the beautiful colors, those are minutes and hours of exposure time. And we have amateur astronomers here that take amazing pictures, but they spend a lot of time gathering data and then using programs to stack all the different images to get the light and get that beautiful look. So, and then again, in astronomy, the events I talk about can take hundreds and more often millions or billions of years to come about. So don't get too nervous. It won't be that scary. The image in my introductory slide is just nebula. It's called the Ghost Nebula and Goblins, and they're there we go. Hello, there we go. Now, so they are called reflection nebula because there's a star behind the cloud that lights up the nebula. Okay, so let's start in our solar system and we'll move forward. Anyone know what? Hello? Okay. You probably know this is a comet. That's Comet Hale-Bopp from 1997, and actually not too scary, but it's got two tails. There's an ion tail, which is lighter gas, and that always points directly away from the sun. So you can always tell where the sun is in relationship to the comet by looking at that blue ion tail. The yellow tail is a dust tail, and comets have those two tails. The dust tail are heavier particles, and so they're more affected by the motion of the comet. So if you see the dust tail on this side, you know the comet's moving in this direction with the dust tail lagging the motion. So you can tell two things about a comet immediately: where the sun is in relation to it, and also the motion. So again, that's not a real scary one. But one other thing, the length of time that it takes a comet to circle the sun is known as the comet period. And this period of this comet is 2,533 years. So we'll see it at some point in the future. So that's not too scary, but there was a comet just a couple of years before it called Comet Schumacher-Levy. And it was discovered in March of 1993. It doesn't have an orbit anymore because it doesn't exist anymore. Does anybody remember that comet, Schumacher-Levy? Well, it was first detected on a photograph taken on March 24th, 93, on the Palomar Mountain Observatory. And the magnitude was about 14, which really need a good telescope to see it. But when scientists studied the orbit, they saw that it made a very close approach in July of 1992. And during this close approach, the unequal gravitational attraction on its near side and the far side, known as tidal force, ripped the comet apart. And Jupiter has a very powerful gravitational field. Its closest moon, Io, is under constant volcanic activity for the same tidal forces that you see. So Schumacher-Levy got ripped apart in 21 fragments. And this is a composite photograph of those 21 fragments coming towards Jupiter. Now, if we saw that coming towards Earth, that would definitely qualify as scary. But a lot of times Jupiter acts as a cosmic vacuum cleaner for us, and its gravitational pull perturbs different asteroids and comets so that we're safe and it takes the hit for us. The fragments hit Jupiter at a speed of 36 miles per second, causing plumes thousands of kilometers high. And that left hot bubbles in Jupiter's atmosphere. And those great dark scars lasted for months. It was a lot of fun for astronomers at the time to look at that. The largest fragment of the comet was 2 kilometers, which is that's pretty big. If it hit Earth, it would make a noise. But it left scars, which are these plumes, the size of Earth. So what you're looking at, Earth can fit right inside that plume left by comet Schumacher-Levy. Very powerful event. It was the first time humans ever saw objects outside of Earth, but in the solar system, collide. And they call that an extraterrestrial collision of solar system objects. Scientists love to big long names to stuff because they work for the government, a lot of them. So one last comment. Comet. And it's not scary, but I had to put it in there because I took this picture in Wayne, New Jersey, from the sidewalk in front of my house. It's the comet that's still out there. I took this, I don't know, about 10 days ago. I just set up my SLR on a tripod. I took a 1-second exposure, and I couldn't see it naked eye. I had to use binoculars to find it. And once I did, I lined up my camera. You might get a glimpse of it. It's getting dull. It's getting dim, but I think it's got a couple more days left on it. So that's the comet. It's called Comet C 2023-A3. I always have a problem. Chuchinshan Atlas. Atlas was one of the machines that discovered it. Chuchinshan was the Chinese astronomer that co-discovered it. It was discovered at the same time. And that was discovered in January of 2023. This comet came from the Oort cloud, which is about 2 light years away. It's about as far out in the solar system as you can get without leaving the solar system. In 2239, it'll be about 200 astronomical units from the sun. And an astronomical unit is the distance between Earth and Sun, which is 93 million miles. So it's about 200 million miles from the sun. And it's got what they call a weak hyperbolic orbit, which means it may not return. It may swing right outside of the solar system because of the way the orbit is. Scientists are not quite sure about where that orbit's going to lead it. But if it does come back, it'll be back in about 80,000 years. So we'll see. Now, asteroids are similar to comets in that sometimes they have orbits that bring them close to Earth. And this is actually an image that was taken from the Los Arecibo radio astronomy telescope in Puerto Rico, which got destroyed in 2020. And this is showing its rotation. It was taken in March of 2001. This asteroid was discovered in 1950. That's why it has the name 1950 DA. And it's 2/3 of a mile across and was estimated to have a 1 in 300 chance of hitting us on March 16, 2880. March 16th. So that's going to ruin some St. Patty's Day parades if it does hit, because that's a big boy for objects to hit the Earth. European Space Agency has a near-Earth Object Coordination Center, and they maintain a list of over 1,500 objects that will come close to Earth or could hit it in a couple hundred years. there's only a few objects that have better than a 1 in 300 chance of ever hitting us, and all of them have a diameter of less than 10 meters. So you can see why this one stuck out on a list that generally doesn't include asteroids that go out 800 years. But here's the good news. In 2015, they reduced their estimate of the chance to 1 in 8,000. And just recently, the 2880 impact was reduced to 1 in 50,000. So this is a lesson that science can be off by quite a lot sometimes, right? Just think of weather forecasts. So when you hear someone say, just trust science to shut off a conversation, that's one of the most unscientific things you can say, because science is all about looking at new data and weighing it against what you know and seeing if what you know holds true given the new data. Now, of course, if you have a friend that's telling you the earth is flat, you might want to tell them to just trust the science. The earth is round. There are times when that does work. But true science always tests their conclusions with new data. And when we send a new telescope up in the sky or build a new one on the ground, we get a lot of new data, and there is a lot of head scratching going on because we're always learning new stuff, and it doesn't always match what we think is going on out there. So here's the 1950 DA asteroid next to some other big boys. Bennu, the asteroid in the middle, is tagged most likely to hit Earth within the next 300 years, according to NASA. It's got a 1 in 1,750 chance for the next 3 years, with the single most likely impact in September 24th, 2182, with a 1 in 2,700 chance. See, they're not big odds. I wouldn't put any money on them, but we are paying attention. So there's no imminent threat to the Earth by any object that we know of. So you can go to sleep soundly tonight. And look this stuff up on the internet. It's kind of fun. There's a lot of good information in there. Of course, if the website has a title of something like the Comet Cult, you might want to skip that page and for a little better information. But this potential danger has caught the eye of NASA. And they've spent a boatload of money, our money, to see if they could change the course of an asteroid known as Dimorphos. This image from Hubble, taken October 8th of 2022, shows a debris field about 285 hours after the September 26th impact. Scientists shot an object the size of a refrigerator into an asteroid the size of a Great Pyramid and then studied the movement. We have an alien walking around, okay? That's all right. Just one kidnapping a night is pretty good. So analysis of the data by NASA's asteroid redirection test, it shows that we actually changed the asteroid's orbit. They were successful in changing the asteroid's orbit. That's the first time humanity purposely changed the motion of a celestial object, and the first full-scale demonstration of asteroid deflection technology. So we had a success in 2022, and NASA's taken it seriously, even the long odds, because you never know. Of course, mini asteroids, known as meteoroids, regularly impact the Earth's atmosphere. They're known as bolides and fireballs, and shooting stars are little specks of dust. When they get bigger, you get a boloid or fireball, and looks something like this. And not all of them burn up. Some of them, if they hit the Earth, we call them meteorites, and people collect meteorites, and we've seen some ancient meteorite craters. So those are called meteorites or insurance claims, depending on the situation. I've seen pictures of a car and a house hit by a meteorite. It's luckily I have not heard of anyone killed by one. So let's stop for a second and just consider the life cycle of a star. And I'm not going to get too far into science today. This is kind of a light look at some scary objects. But just so you understand objects we're looking at, stars all start out as a cloud of gas. And then gravity pulls it together, and they start to heat up. And when they heat up enough, they ignite. They start fusing hydrogen, and they become a protostar. And then when the outward force of the fusion matches the gravity force pulling it in, it reaches hypostatic equilibrium, and the star stays like that. In the case of our sun, it stays like that for 10 billion years. Some hot blue stars only live 100 million years, but they all start out as a dust cloud. An average star the size of our sun, may be up to 8 times the size of our sun, at the end of its life will turn into a red giant after it's done burning the hydrogen. Gravity will start losing the battle, and the cloud will expand. And this is the Reader's Digest version. And what you're left with is a planetary nebula. About half of the mass of the sun will turn into a big gas ring, and the other half will shrink down into a white dwarf. So you'd have half the mass of our sun into a space about the size of Earth. White dwarfs are about the size of Earth. And so you're left with a white dwarf. 20, 30,000 years, all this gas blows off, and then you just have a white dwarf that cools down for trillions of years. We don't know how long it takes because the universe is estimated at 13.8 billion years, and we think it takes longer than that for a white dwarf to calm down. Now, if it's over 8 times the size of our sun, it keeps burning until it gets to carbon. Carbon in fusion requires energy put into it rather than giving off energy. So the star collapses and explodes into an amazing supernova that often outshines a galaxy. So you got a supernova. If it's up to about 60 times the size of the sun, you'll get a neutron star. And if it's more than that, most likely a black hole will occur. So let's take a look at a couple of the remnants that are left by a star the size of our sun. And as I said, what's left behind is a planetary nebula with a white dwarf in the middle. So the non-scary typical remnant would be the Ring Nebula, which you can see up in the sky today. You might even get a chance to take a look at it. This is actually using 3 different wavelengths. What you can see with your eye would be this right here. This is all infrared remnants of when it turned into a just before it was a red giant. So what you would see is actually this, and if you were looking through a telescope, you'd really just see like a smoky, small smoke ring up in the sky through our telescopes. That's about 1,600 light years away in the constellation Lyra. It's a face-on ring, and it's very ordinary. But there's lots of unordinary ones, or a few unordinary ones, and I took a few that I think look like floating eyes in space, just because we're looking at Halloween in a couple of days. So this is called the Cat's Eye Nebula, and it's not only I guess a little scary, but it's a strange object because it has so many rings of gas around it. It's like what you're looking at is over 11 bubbles of gas around this, which is very atypical. Scientists still haven't figured out what it is, what's causing that, what caused it. They think maybe magnetic fields, but it looked like it was pulsing out material every 1,500 years or so. So here's another one. This is called the Helix Nebula, and it was taken by the Spitzer Space Telescope in infrared, which gives it a lot different look than the Hubble visual optical pictures. So it's nicknamed God's Eye Nebula. It's a planetary nebula in the constellation Aquarius, about 680 light years away. So it's one of the closest planetary nebulas to us. It was discovered in 1824. And I don't know, I think it qualifies as spooky. If I looked up and saw an eye looking back at me, that would kind of make me look over my shoulder. This pretty planetary nebula is known as the Little Ghost Nebula because it's round and very faint. But me, I think it looks like another eye looking at me. Maybe I'm paranoid or something. But it looks to me like another eye's looking back at me. And this was discovered in the 18th century by William Hirschfeld, a very famous astronomer. And it's in the constellation Ophiuchus. Ophiuchus. And you got to remember, when a lot of these constellations, objects were discovered, they were discovered by people looking through much less powerful telescopes, certainly no color photography. And so when they named them, what it looked like to them, they were just looking at a ghostly, floating, cloudy image and giving it a name. You know, we have the privilege of seeing them in so much more detail. I'm sure that folks in the 19th and 18th century couldn't imagine the kind of detail that we are now looking at these objects in. This is about 1 light year across, just to give you an idea of how big it is. The closest star to us, Alpha Proxima, is Proxima Centauri, is about 4 light years away from us. So our closest star is 4 light years. So this would take up about a quarter of the space between us and the nearest star. Now this is one of my favorites. It's not an eyeball. It's called the Butterfly Nebula. And it has a much different look than the other planetary nebulas. It doesn't have any kind of roundish look to it at all. This is found in Scorpius. And it's known as a bipolar nebula. And you can see why. You have it, the gas shooting out of both sides. It's about 4,000 light years away from us. And it's got one of the most complex structures of any planetary nebula. And although it looks beautiful, the power that you can't see is just amazing. The spectrum of its center shows the star to be one of the hottest stars known, with a surface temperature of about 450,000 degrees Fahrenheit. Compare that to our sun, a little less than 10,000 degrees, and that gives you an idea of the scale. The original star is estimated to have been about 5 times the size of our sun, although since it's already blown off its shell and we have a white dwarf in there, it's only about 64% of the mass of the sun right now. Again, you can't see the central star because you can see that collar of gas that's not only hiding it, but it's kind of restricting the flow so that the gases are flowing outwards. And the outflows are roiling cauldrons, to use a Halloween word, roiling cauldrons of gas heated to more than 36,000 degrees Fahrenheit, and they're racing across space at more than 600,000 miles per hour, 24 hours a day, 7 days a week. Fast enough to go from the Earth to the moon in 24 minutes. It's just an amazing object. This image was taken in 2009 by the Hubble Space Telescope with a wide field camera. This is the same object. It's just a different image processing. Same information, but differently processed image. So you can see when scientists get data, they can process an image and use color to show what kind of elements they're looking at, or many different purposes, and sometimes just to make a pretty picture, which is what a lot of the folks here do. And I've got one more. Yet another. This is the Butterfly Nebula, same nebula, taken by Hubble with a wider spectrum. So it included ultraviolet light. And it enables scientists to get a better understanding of the structure of those wings of gas. So that's the Butterfly Nebula. Beautiful, but deadly. Okay, so we looked at the remnants on the top. Now we're going to take a look down here. So if we're talking about stars that are scary in a powerful sense, we can't ignore supernova, the explosion of a star. A star collapses and explodes into a supernova, which can outshine an entire galaxy of billions of stars. And to be more precise, we're talking about what scientists would call a type 2 or core collapse supernova. These explosions are so bright, they're visible at immense distances. And you really can't record just how bright they are in film. But this is a supernova, and the brightness here is outshining the entire galaxy that it's part of. Here's an artist's rendition of what an explosion would look like a few seconds after the star went a supernova. Again, outshining 10 billion suns. And you can see the shock wave just pouring out. These explosions can leave behind super dense core known as a neutron star. And I've talked about them quite a bit. You can see it in our archives. But a neutron star can have a mass greater than our sun, but be only about 12 miles wide. So the entire mass of a sun crammed into the space of Manhattan Island. That would be a neutron star. And a lot of them spin around at like 30, 60, or 1,000 times a second. So the sun weighs 333,000 times more than the sun. So imagine the mass of 166 Earths packed into space the size of Manhattan. It's just unbelievably dense, which is what my wife calls me. But that's another Oprah. So here's an illustration of a type of neutron star known as accreting pulsar. In other words, this pulsar on the left has a companion, and it's feeding off the companion, and it's sucking up the gas. And you can see the bipolar jets. They're called relativistic jets, and they're pushing out a lot of energy. Reason why it's called a pulsar is because this thing is turning around and around, and if you happen to be in the direction of the pulsar, it'll sound, if it's going 30 times, if it's rotating 30 times a second, you will hear 60 times a second. You will hear brrr. You can actually hear that in radio waves all the way here on Earth. This was the first one that was actually imaged. It was Hercules X1. It's about 21,000 light years from Earth. And again, it's got a companion star nearby, which it's going to probably devour entirely. Sometimes when you have these accreting pulsars, if they eat enough matter, they can turn into a black hole. And of course, we'll get into black holes in a little while, but they also accrete. It's even more common to see black holes eating up everything in its path. So the neutron star is only shrunk by a few miles, but it's incredibly dense, and it basically has this one has a mass about 2.5 times that of the sun. The system has previously showed regular variations in brightness, and is of interest to scientists. There's another one I'll just touch on. Another accreting pulsar is the Black Widow pulsar, also known as pulsar. Well, I won't even read all the. It's a dangerous partner to have. Again, the pulsar itself is only the size, a little bigger than New York, maybe Washington, D.C. And it's getting bigger by feeding off its mate, which is a cool, lightweight brown dwarf, which is about as cool as a star can get without becoming like the planet Jupiter. So if you have something a little bigger than planet Jupiter that actually starts to go under nuclear fusion, it'll become a brown dwarf. These two stars orbit each other about 94 minutes in a deadly dance. So this is a artist's conception. It's not a photograph. The actual photograph is kind of boring. So I found this one. It's a lot cooler to look at. And again, the beam from the pulsar strips layers away from that star. This pulsar spins at about 600 times per second. It's known as a millisecond pulsar. So imagine the island of Manhattan spinning around at 600 times a second. I mean, that's just mind-blowing. And also, it's about 10,000 degrees Fahrenheit on one side of the star. because of all the radiation, the side of the brown dwarf facing the star, even though it's just a cool brown dwarf, it's about as hot as our sun gets because of all that activity there. Now we come to a black hole, and I picked one of the more spectacular black holes. This is known as an optical. Yeah, this is a giant black hole. If you see in the middle, there's a drawing of our solar system, and of course, this is not an image taken with a telescope. This is another artist's conception. You can't photograph a black hole because light doesn't leave a black hole. When it's accreting matter, you can take a picture of the accretion around it, and that's even kind of tough. But this black hole is just mind-blowing in size. It's the scariest black hole I know of. You know, a lot of black holes can be small. They can be the size of neutron stars. They come in all different sizes. But something this large is very rare, and it's even rarer to find one. This is another artist's conception of an accreting black hole. It's known as an optically violent variable, a hyperluminous black hole, and it belongs to the most energetic subclass of galactic nuclei. So you'll find this in the middle of a galaxy. A lot of galaxies have black holes, and most black holes are accreting because they're near matter, and as soon as they're near matter, just their gravitational force itself sucks up the energy, and it spirals into the black hole. This one's really hot, about 300 trillion times as luminous as our sun. So if this, we'll call it a quasar, which is its name for an accreting black hole. If this were 280 light years from us, it would give as much energy per square meter as the sun does from Earth. At 280 light years away, that just gives you an idea of the power we're talking about. 300 trillion times as luminous as our sun, and over 25,000 times as luminous as the 100 to 400 billion stars in our galaxy. It's just mind-boggling. Okay, we're back in our galaxy. Has anybody heard of the Andromeda Galaxy? The Andromeda Galaxy is our closest galaxy, and you can see it with binoculars on a night like this. It's out there. It's near the constellation Pegasus, and it's another spiral, just like our Milky Way. The Andromeda Galaxy is very dim. You'd find it by looking for the square of Pegasus and then moving here, and the Andromeda Galaxy would be right here. You take these two stars and star hop to the Andromeda Galaxy, or you look at Cassiopeia, the big W in the sky, and it'll point right to it. So this shows us if the Andromeda were bright enough for us to see the full extent of it, instead of just a real dim, fuzzy object, if it was bright enough to see the full extent, that's how the size would compare to our moon, if we could see it. Even more realistically, that's how the Andromeda Galaxy would look at sunset if it was bright enough to see the full extent. So that is the size difference between the Andromeda and the moon, if we could see how big it was from up there. What you'll see in binoculars is you'll see something that pretty much covers the entire field of your binoculars. And when you're looking at a nebula or a galaxy, a good trick is not to look right at it, but look past it. And if you look past it, you'll be looking at the object with the cones on the side of your eye, which are more sensitive to light. So you'll actually see the Andromeda Galaxy grow if you look past it and not directly at it. It'll come in handy if you look at a couple objects tonight. Okay, so what? It's a gorgeous galaxy. It's the closest one to us, and And what's so scary about it? Well, um, just about everything in our universe is moving away from itself. They call it redshift. As things are moving away, the light is shifted towards the red, and that means it's moving away. It's the Doppler effect. But there's about 100 local galaxies that are actually moving towards each other, blue shifted. And the Andromeda galaxy is moving towards us at 190 miles per second when measured with respect to the sun. That means that the two galaxies, the Milky Way and the Andromeda, will collide in about 4 to 5 billion years. But don't worry, the sun is also going to fry us right around that time. So I think we're going to be fried before the galaxies collide. But it wasn't until 2012 that observations from the Hubble telescope confirmed that, yes, they are going to collide. It's now taken as a fact, but we'll see. Maybe they'll get more data. But right now, it's a sure shot. So there's another photo of the Andromeda galaxy. Here's some pictures of what those galaxy collides will probably look like as the two galaxies start to interact. And it's not as catastrophic as you'd think. Like there's 4 light years of space between us and the nearest star. So these galaxies, they'll certainly affect each other, but it's not like every sun is going to crash into another star. But it'll be very, very interesting. There's a great a photo of galaxies right in the middle of collision. They're merging galaxies NGC 4568 and 4567. And these two merging galaxies are known as the butterfly galaxies due to the butterfly look. And don't confuse this with the butterfly nebula we saw. If we put the butterfly nebula in there, it would be a tiny pinpoint around one of these stars. So this is immeasurably larger. It's two galaxies forming a butterfly rather than just some gas forming a butterfly. But that's kind of a sneak preview of what it's going to look like when galaxies start to interact. And there's a relative size of our Milky Way along with Andromeda and the Triangulum galaxy, which is right near the Andromeda, and it's expected to get sucked into this galactic merger. It may be the third to get merged in, or it may merge in with us before Andromeda. It's really hard to figure out three body problem, especially when they're galaxies. But if you're going to make a merger, you might as well make a cool merger. And these are two galaxies merging. Whenever you see galaxies merging, you'll see some blue stars. And the blue stars are brand new, very hot young stars that are caused by the gravitational interaction between the two galaxies. And so that's what you're looking at. The piercing eyes are two distant galaxies in the middle of a head-on collision. And it's surrounded by a bunch of new stars and old stars. Red stars are usually old stars. There's actually some galaxies in here too that are not part of the system, right? There's a galaxy. There's a whole bunch of galaxies. But this is two galaxies, new stars being formed. And the new stars are not going to last too long. The ring structure that outlines that face will be around for about 100 million years, while the merger of those two galaxies will take 1 or 2 billion years. And this object is known as ARP Mador 2026 424 for anyone interested, probably online, Googling me as I speak. It's about 704 million light years away from Earth in the constellation Microscopium. And Hubble scientists captured this image in 2019. So it's not that old. It's about 5 years old. They used the surveys. This was part of a survey used to pick out objects that the James Webb Space Telescope was going to look at. They did a lot of surveys with Hubble in a couple of years before James Webb was launched. James Webb is now up there for 2 years, and I've done a talk on that. That's available in our archives. but they used those surveys to figure out what they really wanted to point the James Webb at. So let's take a look at some more Halloween shots. These are scary looking, but not too dangerous. These are two galaxies colliding with a third, all gravitationally attracted. It's called the Devil's Mask. It's a triplet in the constellation of Peacock, and it's part of IC 4845. It was discovered in 1836. Here's an example called Gravity's Grin. There's two distant galaxies for eyes, and they give it quite a whimsical appearance. One thing about supermassive objects, and Einstein predicted this back in the 20s and 30s, but we didn't confirm it out in nature until the 70s. But one of the things that he predicted was gravitational lensing, and that is that the black holes and the black matter is so massive here that it actually bends the fabric of space-time. And there are objects behind these two galaxies that we could not see if it wasn't for gravitational lensing. And the light actually travels around those objects and very distorted, but these are galaxies that have been magnified and distorted by the way that the black holes have bent space-time. It's really amazing. And we're seeing more and more gravitational lensing. I spent a lot of time on a different talk on that, but sometimes you get cool things like this, Gravity's Grin. It's also a nickname, the Cheshire Cat galaxies. And it's just two elliptical galaxies that are framed by the arcs of gravitationally lensed galaxies. A lot of dark matter in there. Here's one. This is called the Ghost Nebula. It's just a reflection nebula. It's called a reflection nebula because there's a star that's lighting up the nebula. It's not producing its own light. It's being lit by a bright young star. This is in the Cephus constellation. This is the Ghost Nebula. And it's a reflection nebula as well in the Cephus constellation. It's about 1,500 light years away from Earth. I like this picture of the ghost better. It's the same nebula. It's a lot wider, and it includes the goblins. This was the picture that we looked at the beginning of our talk. It's over 2 light years across, this picture. And there's several stars embedded whose emissions are I mean, you can see them right here that are lighting up these gas clouds. So they look a little scary, but they're just harmless gas clouds. It's like looking at clouds in the sky and seeing what they look like. This is another cool one. This is known as, this was in the Carina Nebula, and it's known as Mystic Mountain. It's a dust gas pillar, very similar to the Eagle Nebula, which is a little more famous than this one. This was also taken by Hubble, and the pillar is about 3 light years high, which is, again, very similar to the Eagle Nebula. The Skull Nebula, the Rosette Skull Nebula. That is a scary looking dude. Another emission nebula with a radius of about 65 light years. It's photographed by Hubble, and it can be found in the constellation Monoceros. There's a cosmic bat situated in Ophiuchus. Rarely imaged because it's dark nebula. It's a really dark, dense cloud that's blocking out the light from the background stars. And this is a really tough one to take a picture of. Here's another bat. That's the Bat Nebula that's in the Veil Nebula. And one of our members just made a really great image of this. This isn't his. This is one I found on the internet. But the Veil Nebula is a large supernova remnant. It covers about 3 degrees in the sky. This here covers about a half a degree. So it's about the same apparent size as the moon, which is pretty big when you think about it. You're looking at something that's, much farther away. It's 1,400 light years from planet Earth, and it covers the area of the moon. Okay, the new James Webb telescope showed this amazing star in amazing resolution. They're calling it a Death Star, and it's in the constellation Gullibilicus. And if you take a real close-up look at this star, you'll notice that it's really a slice of chorizo sausage that a French physicist used as an internet prank. Kind of nice. Makes me hungry. Since we crossed over to the ridiculous, here's a meme I recently saw comparing the Ring Nebula to an eyeball and a dying star to the birth of a cell and a stringy structure of the universe to brain cells. And he's asking, what if the universe was a giant living organism? Kind of ridiculous. Or is it? Exactly. Here is NGC 4612, a spiral galaxy at a distance of about 100 million light years. And it really looks like an eyeball. Scientists did not know that ring that's making it look like an eye even existed, because you can't see visible or infrared. They had to find that in radio waves. So they're using an optical image for the galaxy, and radio waves turned into something we could see. And that's NGC 4632. And that's where I'm going to end it, with the universe looking back at you. And thank you so much for your attention.
I'm going to hand you that so you can get that. It's already on. So I want to thank everyone for coming out. Because I saw a number of you sneak during the presentation, I'm going to go over the safety briefing again. If you need the restroom, that is the porta potty in the back. To my left, your right. It is illuminated by red for ease of seeing. In addition, we do have a museum area and gift shop, which I will be manning after question and answer session. I notice that a number of our people online have questions, so I'm sure you do too. When we go to leave here, we are using our headlights. We prefer not getting run over, and I'm sure you would prefer also not getting run over. That way you can go out and trick or treat afterwards on a future date. However, if we have any flashlights or whatnot, do try and keep those pointed towards the ground. We don't need to accidentally blind people for no reason. In addition, I have candy. Feel free to take some candy. Please take some candy. Save me from myself. If I have to eat an entire bag of Halloween candy by myself again, I'm probably going to regret it. So save me.
Again?
Yeah, last year no one took candy. It made me sad, and also made me very much larger than I was. Besides the point, we do have volunteers running telescopes, so that do listen to the volunteers and see what they are seeing. So how question and answer session is going to work: if you are here, you're going to raise your hand and wave it about, and wait till I bring you the microphone. That way the people online can also hear your question. People online, you get the easy job of just typing. All right, so I'm going to start this off with the first online question. And will the current comet get broken apart like the one you showed and hit things in our solar system?
There's no indication that it'll pass by any large body large enough to have the tidal force. So what'll happen is every time it comes around, it'll lose more of its material just from the sun evaporating. The ice, that was good. The ice in the rock. So no, it won't get broken apart.
All right, was there a question out here? All right.
So what's the big next celestial event? You know, like a comet or a solar eclipse in our area?
in our area, there's not going to be a solar eclipse for about 30 or 40 years. Comets, you never know. You know, they're discovered about a year or two before they become visible. There's going to be another comet that may be visible. You can't even predict their brightness, so sometimes they get overhyped and they fizzle out. There's always lunar eclipses to check out, and you know, if you just type sky and telescope in your browser, they have a page that's called "What's in the Sky This Week," and you can take a look and see what's coming into conjunction, what's looking cool. Saturn's out there right now. You might get a nice view of that. But as far as events, nothing really sticks out in my mind. You, Kim?
I think the only event I could even think of is the one we've been waiting on since April, which is the supernova in Corona Borealis.
Oh yeah, yeah. They've been promising that for a few months.
Yes, and mostly it's hurry up and just stare at it and wait. And we've been waiting for months, so we're a bit impatient now. So who knows? That might come out. Um, but yeah, unfortunately, a lot of us don't plan that quite that far ahead in in our schedule. All right, was there another question out here? All the way in the back.
Hi.
Hi.
So when you're using a telescope, are you just like staring through it and hoping to see something, or how does that work?
No, you know, when I started, we used to do something called star hopping. You look at a star map, see where you want to go, and then you look from brightest star to dimmer until you hop over to it. Now telescopes have GPSs in them. Once you're aligned, you just push the object that you want to look into, and the telescope swings over, locks in the image, and you're looking at the image. It's great for slackers like me.
I mean, you can certainly just set up a telescope and go, I wonder, and just scan the horizon like a pirate. Um, but yeah, it is much. Usually, people are like, they look at a what's up in the sky today map and go, I want to see the Veil Nebula, and then they figure out where the Veil Nebula is and look through the finder scope and go, yes, I got it, and then slowly increase magnification on your actual scope. Our next online question is the comet even still, I think they're talking about the one we have currently, is the comet even still visible through telescope or camera?
Yes, I believe it's a couple more days. They were trying to find it when it was a little brighter out. I'm not sure if they were successful, but okay, excellent. So yeah, there it is. It is visible, and if it's visible through a telescope or binoculars, it's certainly visible in a camera, which gathers more light than your eyeball does.
All right, another question out here. Oh, yeah, thank you for waving the hand around because, like I said, I'm a little night blind looking at a screen.
Where is that supermassive black hole located?
Oh, where was that thing? Hold on, I'll check it out. You can take another question. And by the way, no one will hurt my feelings if you go to look at a telescope. It's a beautiful night. Let me see. Let me I'll get back to you. Ask another
I
question.
think there were a couple
can't
of
remember where
different
that
black
was.
holes.
Yeah,
Was
he's
it
talking
in
about the super,
Sagittarius?
the really really big black hole.
Isn't that in Sagittarius? Sagittarius?
Well, there's one.
However you pronounce it. I can't pronounce it.
There's one in Sagittarius. It's actually the center of the Milky Way.
That might be why I remembered it.
But this one,
All right.
yeah, keep going. I
The next online question, and I'm not even going to be able to answer this one. What would be the return on investment in betting those odds if this were horse racing? They're talking about comets
Yeah.
smashing into Earth.
the asteroids. You know, if you're around to collect it in 2880, God bless you. I don't think I'd bet on that.
Yeah, unfortunately, that math is beyond me. And also, I don't gamble like that. So you'd have to ask someone much more in tune with their mathematical side. But that is the glorious thing that is the internet. Right. Was there another question? Bueller? Right. So next online question.
Yeah, I did not write down where that black hole was. I usually have that stuff on there. Sorry.
Are there any particularly scary or interesting space objects in the southern hemisphere? It seems like many of the examples he gave are northern hemisphere things.
Yeah, there are, and there were a couple of them that that were in the southern. But yeah, just start Googling Ghost Nebula, Bat Nebula, you'll get a whole bunch of them.
Also, a great program to use, Stellarium. And for the person who had asked the using the telescope thing, whether you just point it, Stellarium is a great resource for, you type in your coordinates and it'll show you your night sky for what's up and in your area. And you can also change the time of day so you can see where it should be in the sky. Great resource for doing that.
And I had a couple of objects that were in the Korean Nebula, which is only visible from the south of the equator.
Right. Like I said, if you have any questions, do raise your hand. Let's see. The next online question: could Jupiter become a brown dwarf?
No, it's not big enough. It has to have enough mass that the gravity would collapse it. It's got a hot center, but it's not going to ignite. It needs more mass. I couldn't tell you exactly how much more mass. Probably another 50%, but it needs more.
I was going to ask you, how much bigger does it need to be?
Of course.
Let's see. And one of our regular viewers and moderators on Twitch, regarding the pulsar that spun 600 something times a millisecond. If you get enough New Yorkers riled up about slicing a bagel the wrong way or the best type of pizza, it might spin that fast.
True enough.
So, anyhow.
New York is constantly spinning out of control.
And one of our viewers wanted to say hi to their friend Melissa. So, hi, Melissa. Any people online, if you have any questions, do get those in, because I'm wrapping this up shortly. Any questions out here? All right.
A few years back, I learned about this small meteor. It's about 300 meters or 350 meters. It's called the red meteor, or they call it asteroid Apophis. And I think NASA found it in 2004. But supposedly it's going to get super close in 2029, and then it's going to come back in 2036. I was wondering if you guys ever heard of that.
I did, and I don't remember the exact details. I think one of the predictions was that it was going to come close enough to go pass between Earth and the Moon, which is...
You actually had Apophis on the screen with the Empire State Building, a large dude, Bennu, and then it was Apophis.
Did I? Because
Yeah.
the one they're talking about, I think, was smaller.
Believe it or
than
not,
that.
I pay attention during the presentation. I'm just not over there scrolling on my phone for fun. Yeah, see?
Apophis. 1214. Yeah. For some reason I thought that the one you were talking about was smaller than that, because that's pretty big. 1214.
All right. So I want to thank everyone for joining us here and online. Online people, do us a favor, hit those like and subscribe buttons. They're completely free. Follow us on our social media. Check out our website, uacnj.org. And with that, everyone have a great night, clear skies, and good seeing, and happy Halloween.
Yeah, thanks. If you're online, get outside, please. It's a great night.